Salam and welcome everyone. So today we're going to be working on the question on the screen that says calculate the pressure exerted by 1.0 mole H2S behaving as a van der Waals gas when it is confined under the following condition: 500 Kelvin in 150 centimeter cube. So calculate the pressure exerted by 1.0 mole of H2S gas. The first thing you have to note is that this H2S gas, we're told that it acts as a van der Waals gas, and they told us the number of moles for this gas is 1.0 mole. We're also told that it was confined under the following condition, which is just the temperature, which is 500 Kelvin. And then we were told that the 500 Kelvin was in 150 centimeter cube. So 150 centimeter cube. And we're told to determine pressure. Now, the first thing you have to notice, because this is a van der Waals gas, you already know that to find pressure, there's just one equation that we use, which is pressure equals RT, where R is the gas constant, T is the temperature, is equal to the molar volume minus B meaning the one of the van der Waals parameters, and then minus A, which is the second van der Waals parameter, divided by molar volume all squared. We're lucky enough that we have the R, we have T. R is the gas constant, so constant value is a constant. T, we have that as 500 Kelvin. We have the volume. We have that, but we don't have the A and B given to us. Now, whenever you see a question like, it's important for you to know that at the back of the physical chemistry Atkins textbook, which is a textbook I got this question, there is a resource section, and in that resource section, you get all of the information you need for each question. So when you go to the back of the textbook and you look for the A and B for H2S, you're going to get those specific values for A and B. So looking at the back of my textbook, I basically determined that the value for A, the van der Waals gas, is 4.484 atmosphere dm6 raised to the power of mole squared. And then the value for B was just simply 4.34 times 10 to the power of negative 2 dm cube per mole. So that's basically it. So now we have the value for A and B. And the thing that makes sense is that, okay, I told you guys already about volume, right? You know, we have the value for R, T, A, and B. And then we also have the value for volume. But this question is asking us for molar volume. And to determine molar volume, you have V equals, sorry, the molar volume, you have Vm. So molar volume is equal to the volume divided by number of moles. But then there is an issue. The issue is simply this: we see that the parameters that we're given is dm, the unit for volume is decimeter, and then the unit for volume for B as well is also decimeter or decimeter cube. But then our question is telling us 150 centimeter cube. So we cannot go ahead and just find the molar volume. We have to first of all convert from centimeter cube to decimeter cube. So we have to go now from centimeter cube, so 150 centimeter cube is going to give you what in decimeter cube. So that is what is the requirement. So let's remember 10 centimeter is going to equal 1 decimeter. So let's do a quick conversion refresher. And then you have 10 centimeter is equal to 10 centimeter is equal to 1 decimeter. So 10 centimeter cube is equal to how many decimeter cube? So you have 10 times 10 times 10 will give you 1000. Centimeter times centimeter times centimeter will give you centimeter cube. And then 1 times 1 times 1 give you 1 decimeter times decimeter times decimeter is decimeter cube. So 1000, okay, centimeter cube would give you 1 decimeter cube. Hence, you're giving 150 centimeter cube. So 150 centimeter cube would give you what? X, right? So let's cross multiply. You have 1000 centimeter cube X is equal to 1 decimeter cube times 150 centimeter cube. So you divide both sides by 1000 centimeter cube. So you end up with canceling out the left side, and then you cancel out centimeter cube here, centimeter cube here, 5 here, 5 here. So you end up with X equals to 115 divided by 100 decimeter cube, which is the same thing as X equals 0.1 5 decimeter cube. Now, let's not forget X is just simply volume. So V is equal to 0.15 decimeter cube. Now we've successfully found what volume is in decimeter cube. Now we can now determine the molar volume. So molar volume is just volume divided by number of moles. So that would be 0.15 decimeter cube divided by number of moles, which is 1.0 mole. So divided by 1.0 mole. So the molar volume is just going to be 0.15 decimeter cube per mole. So successfully, we've determined what the molar volume is and we have all the parameters that we need. So I'm just going to quickly rewrite all the parameters so we don't have to keep going back and forth. So we let me just give me like 2 seconds. Let me just rewrite it. So you have the temperature is 500 Kelvin. A is 4.484 ATM DM6 per mole squared. And then B is 4.34 times 10 to the power of negative 2 dm cube per mole. And then, of course, R is the gas constant. So now, substituting, we have P is equal to RT divided by Vm minus B minus A divided by Vm squared. So we're going to substitute all of this information in this equation. So you have the gas constant P is just simply 0.08206 dm cube atmosphere divided by mole Kelvin times temperature, which is just 500 Kelvin, divided by Vm. So molar volume is 0.15 dm cube per mole minus B, which is just 4.34 times 10 to the power of negative 2 dm cube per mole. So minus A, which is just 4.484 ATM dm6 per mole squared divided by Vm squared. So that would be 0.15 dm cube per mole all squared. So yeah, that's it. So of course, let's simplify. I can cancel out the Kelvin. That's how far I can simplify. I have to do the multiplication first to make this simplification easier. So next I work with the numerator right here. 0.08206 times 500 will give me 41.03 atmosphere dm cube. Of course, I'm just rewriting the rest of the units per mole. So that's the first one. And then you've got the denominator, which is just 0.15 minus 4.34 times 10 to the power of negative 2 is just 0.1066 dm cube per mole minus 4.484 divided by 0.15 dm cube per mole all squared would simply be, so let me just write 4.484 dm6 atmosphere per mole squared divided by 0.15 dm cube per mole all squared would just be 0.0225 dm6 per mole squared. So cancel out dm cube, dm cube, dm cube, dm cube, mole, mole. Cancel out dm6 mole squared, mole squared. So you can see on both sides that you have atmosphere remaining here and atmosphere remaining, which makes sense. And that hints to us that work is being done correctly, mainly because the units for pressure is atmospheres. So P is just simply going to be 384.8968 atmosphere minus 199.28889 atmosphere. So pressure is just simply 185.6079 atmosphere. I also wanted to mention that, like, while this is very correct, let's not forget that we're dealing with a chemistry question here. We cannot just leave our information, our final answer, in just a bunch of raw values. We have to approximate. And to approximate, we have to pick the lowest number of significant figures, and we approximate to that lowest number of significant figures. So if we go back to our question and see the values we're given, number of moles was in 2 sig figs, and then we have temperature in 3 sig figs, and then of course volume in 3 sig figs. So what this is telling you is that 2 sig figs is the lowest number. We have to approximate to 2 sig figs. So approximating to 2 sig figs right here, I can just simply I'm going to do it in scientific notation. So what I end up with is pressure is equal to 1.9 times 10 raised to the power of 2 atmosphere. So this is basically the answer to this question. 1.9 times 10 raised to the power of 2 atmosphere. So yeah, that's it. That's basically the answer. If you have any questions, please put in the comment section. I have done a very similar question on this channel and it's currently on the screen. So make sure you check the description box and click on the link so that you can watch that video and get more practice done. If you're students who are struggling in any of your STEM related courses or trying to improve and succeed, make sure you email me at shahabitutoring@gmail.com. I help students in middle school, high school, and college to succeed and be the best version of themselves in academia. I also help mentor students who are trying to navigate their academic life and career path. So if you would like my services, and I've been told I'm a great tutor and mentor, make sure you email me at shahabitutoring@gmail.com. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.